Hello everyone, I'm glad to present our late-breaking work exploring stage lighting education in Metaverse. The ongoing evolution of immersive technologies has led to a diverse range of studies investigating VR's impacts on various learning scenarios. However, much of the existing research has been confined to one-time lab sessions or experiments, lacking a comprehensive understanding of VR in designing an actual course perspective. Therefore, we want to explore the actual use of VR in stage lighting education for the Technical Theatre Arts course at the Hong Kong University of Science and Technology. We aim to answer two research questions. First, what are educator and schools managers' attitude and design requirements? Second, what are the lessons learned while building the initial VR lighting education prototype? We adopt participatory design research practice. We co-designed with 4 key stakeholders: the course instructors, a stage lighting practitioner, and 2 school managers for 6 months. We then performed thematic analysis to retrieve insights and requirements from their feedback. The primary motivation for utilizing VR in stage lighting education comes from its feasibility and safety. VR enables students to learn at any time and place and explore without any risk of damaging expensive professional equipment. Moreover, the stakeholders pointed out that the role of VR is to quickly impart knowledge and concept before students proceed to actual practice. We also derived 4 design requirements. First, the system should be used not only for teaching but also for doing assignments. Second, the level of realism should serve the purpose of learning. Third, the system should offer natural communication for lecturing and teaching. Lastly, the user interface should be intuitive and user-friendly. Based on these requirements, we implement an VR lighting education prototype for the theater course. We allow students and teachers enter a collaborative stage for teaching and lecturing. Moreover, we designed a 2D WIM-based user interface for users to interact with lights in a very familiar ways to the desktop. During the design process, we have 2 lessons learned. Learning objective would be different in the course. Realism could be dynamic for different students to fit their learning goal in the VR environments for personalized learning. Moreover, we should explore the optimal distribution of VR and reality-based course, ensuring that students learn theoretical concepts in the virtual auditorium and apply them in the real-world scenario. In the future, we plan to explore more novel education interaction in VR, conducting long-term studies in the course to measure the effectiveness and evaluating how well can VR assess students' mastery in lighting to understand the potential of doing assignment exam in VR.